10th plus 2 ஒவ்வொரு ஆண்டும் தொடர்ந்து மாநில அளவில் பல சாதனைகளை புரிந்து வரும் நாமக்கல் குறிஞ்சி கல்வி நிறுவனங்களில் சிபிஎஸ்இ பாடத்திட்டத்தில் சீனியர் செகண்டரி பள்ளியாக தரம் உயர்த்தப்பட்டு ஐஐடி நீட் தேர்வுகளுக்கு பல வெற்றியாளர்களை உருவாக்கிய ஆசிரியர்களை முழு நேர ஆசிரியர்களாக பணியமர்த்தப்பட்டு தினம்தோறும் வகுப்புகள் நடைபெறும். நாமக்கல் குறிஞ்சி மெட்ரிக் அண்ட் சிபிஎஸ்இ +1 வரை அட்மிஷன் முன்பதிவு நடைபெறுகிறது.
Previous class we discussed the one of the chapter pH scale in ionic equilibrium. So ionic equilibrium lessonல pH scale pH of the solution எப்படி find out பண்ணலாம் அப்படினு பாத்துறோம். So இன்னைக்கு கிளாஸ்ல நம்ம என்ன பார்க்கறோம்னா common ion effect. So common ion, that means one of the ion is present as a common in two different components. So ரெண்டு காம்போனன்ட்ல காமனா பிரசன்ட் ஆயிருக்க ஒரு அயன்னால what are the effects are produced. So அத நம்ம இங்க ஸ்டடி பண்ண போறோம். சரியா? So what is mean by common ion effect? So dissociation of weak acid is suppressed in the presence of the salt containing common ion is called common ion effect. So in the common ion effect எதை யூஸ் பண்ணி எக்ஸ்பிளைன் பண்றோம்னா which is explained by using the weak acid or weak base, that means weak electrolytes யூஸ் பண்ணி நம்ம எக்ஸ்பிளைன் பண்ண போறோம். So the weak acid weak base அப்படிங்கறது நம்ம strength of acidsலயே பாத்துறோம். So weak acids அப்படினா என்ன ஆகும், which is partially dissociated into an ions, that means the solution which contains the undissociated molecules and dissociated ions both are present in the solution. So strong electrolyte, so strong acid na eppadi irukum, weak acids na eppadi irukum paathirundom. So strong acids means completely dissociated into an ions, there is no unionized molecule. So but for weak acids, so there is a partially dissociated into an ions, the solution which contains the dissociated ions and undissociated molecules both are present. So அந்த concept use பண்ணி இந்த common ion effect study பண்றோம். So the common ion effect is explained on the by using the weak acid or weak base. So நம்ம இங்க என்ன எக்ஸாம்பிள் எடுத்துக்கிறோம், weak acid எடுத்துக்கிறோம். So one of the weak acid is acetic acid. Acetic acid is partially dissociated. So partially ionization காக தான் நம்ம என்ன யூஸ் பண்றோம், we use the equilibrium sign. So acetic acid is partially dissociated into acetate ion and H+ ion. Acetate ionium H+ ionium produce பண்ணும். So by adding the acid, by adding a salt of the own acid, இதே acid ஓட salt form பண்றோம். So when the salt is formed by treating an acid with base, acid base கூட ட்ரீட் பண்ணும்போது, but acetic acid is a weak acid, so it must react with one of the strong base, sodium hydroxide, it produces the salt sodium acetate. So acid எடுத்துட்டோம், அந்த acid ஓட own salt நம்ம form பண்ணோம். So the salt எப்படி produce ஆகும், by treating an acid with a base. So acetic acid is treated with a base sodium hydroxide, there is a formation of sodium acetate. நம்ம weak acid weak base ங்கதெல்லாம் partial ionization னு சொன்னோம், strong acid strong base னா complete ionization னு சொல்லிருந்தோம். But all salts are completely dissociated into an ions, strong electrolyte. So salt எல்லாமே strong electrolyte, that means complete dissociation will occur. So forward arrow mark sign மட்டும் கொடுக்கிறோம். So sodium acetate is completely dissociated into an acetate ion and Na+ ion. That sodium acetate is added to the acetic acid. So initially we have to take the acetic acid only in water, it dissociated into an acetate ion and H+ ion, it attained the equilibrium condition. To that solution we adding the sodium acetate, it is a salt of acetic acid, acetic acid ஓட salt add பண்றோம். That salt is completely dissociated into an ions, sodium acetate, acetate ion and Na+ ion, which is present in that same solution. So what is mean by the equilibrium, நம்ம 11th portionலயே பார்த்திருக்கோம். Equilibrium means the reactant and the products are present in a definite quantity. So particular quantity ல change ஆயிரும், particular quantity ல present ஆயிரும். But by adding the sodium acetate, the concentration of acetate ion increases on the product side. Product side ல acetate ion ஓட concentration என்ன ஆகும், increase ஆகும். So due to the increase in concentration of the acetate ion, the dissociation of acetic acid will be decreases. So Lee-Chatelet principle நம்ம chemical equilibrium lessonல படிச்சிருக்கோம். So what is Lee-Chatelet principle? A system at equilibrium is disturbed by changing the concentration or pressure. So எதா ஒன்னு வச்சு change பண்ணும்போது, then the equilibrium will shift its direction that tends to nullify the effect of disturbance or stress. So என்ன disturb பண்ணுமோ அந்த disturbance rectify பண்ற directionல equilibrium automatically shift ஆயிடும். So initially it attained the equilibrium, first one மட்டும் consider பண்ணோம், acetic acid, dissociation of acetic acid attained the equilibrium condition, but by adding sodium acetate it produces excess of acetate ion, so the equilibrium will be disturbed. The equilibrium disturb ஆகுது, that means the concentration of acetate ion increases so that the equilibrium will shift towards the left hand side. அப்ப equilibrium என்ன, left side shift ஆகுது. So in the left side we have the reactant molecule acetic acid. So the dissociation of acetic acid will be decreases. That is the statement of common ion effect. So dissociation of weak acid such as acetic acid is suppressed or reduced, both are same. So is suppressed in the presence of common ion sodium acetate, the salt which contains a common ion. So this is a salt which contains the common ion as acetate ion. ரெண்டுமே காமனா present ஆயிருக்க ஒரு ion-நால அதோட dissociation என்ன அதுப்பா suppress ஆகுது. That is a common ion effect. It is one of the important topic. The common ion effect is explained by using the weak acid or weak base, and then it is based on, it is further explained by using the Lee-Chatterley principle. So Lee-Chatterley principle physical and chemical equilibrium lesson la already பார்த்திருக்கோம். So Lee-Chatterley principle means if a system at equilibrium is disturbed by any stress, then the equilibrium will shift its direction to nullify the effect of disturbance or stress. என்ன ஸ்ட்ரெஸ் ஃபார்ம் பண்றோமோ அந்த ஸ்ட்ரெஸ்க்கு அகைன்ஸ்ட் அதை ரெக்டிஃபை பண்ற டைரக்ஷன்ல ஈக்விலிபிரியம் ஷிஃப்ட் ஆகும். ஸோ டியூ டு த அடிஷன் ஆஃப் sodium acetate, the concentration of the acetate ion increases on the product side. So to maintain the equilibrium will shift towards the backward direction. That means more number of acetic acid molecule is produced, so that the dissociation of acetic acid will be reduced by adding the salt which contain the common ion. This is the common ion effect. So next one is buffer solution. Next topic, buffer solution. So in the buffer solution நம்ம எதை யூஸ் பண்றோம்? Buffer solution is a mixture of this acid and its own salt. So இங்க weak acid, weak base யூஸ் பண்ணி தான் நம்ம பண்ண போறோம். So buffer solution அப்படிங்கிறது solution to resist the changes in their pH by adding a small amount of acid or base. So acidயோ பேஸையோ ஆட் பண்ணும்போது அதோட pH வேல்யூ சேஞ்ச் ஆகாது. So last classல பார்த்திருந்தோம் pH scale அப்படி. pH scaleங்கிறது பார்க்கும்போது என்ன சொல்லியிருந்தோம்? If pH is less than 7, it is an acid. pH is greater than 7, it is basic compound அப்படின்னு பார்த்திருந்தோம். So the pH value by adding an acid என்ன சொல்லியிருக்கோம்? Less than 7. To that solution we adding some more amount of acid. கொஞ்சமா வேற acid add பண்றோம். அப்ப acid add பண்ணும்போது pH value என்ன ஆகும்? Reduce ஆகும். But the solution which resists the changes in their pH, அதோட pH value change ஆகாம resist பண்ணுது. To avoid the changes in their pH of the solution by adding a small amount of an acid or base. So கொஞ்சமா acidயோ baseயோ add பண்றதுனால there is no changes in their pH is called as a buffer solution. So the buffer solution means it is a mixture of weak acid and its own salt. என்ன ஆசிட் எடுத்துக்கிறோமோ அதோட own salt ஓட சேர்ந்த காம்பினேஷன் தான் இந்த buffer solution. The own salt is produced by treating the acid with a strong base. That is a buffer solution. Types of buffer solution. So buffer solution என்ன சொல்லியிருந்தோம்? The solution which resists the changes in the pH of the solution by adding a small amount of acid or base. So ஒரு solutionல acid add பண்ண என்ன changes நடக்கும்? What we expect? There is a decrease in their pH value reduce ஆகும். Or by adding an base. So base add பண்ணும்போது pH value என்ன slightly increases than its original pH value. So the changes of pH வந்து resist பண்ணுச்சுன்னா அது என்னன்னு சொல்லலாம்? Buffer solution. So we seen about the two types of buffer solution. One is acidic buffer solution. The another one is basic buffer solution. So இந்த solution நம்ம prepare பண்ணி சொன்னோம் weak acid and its salt. அது weak electrolytes ஓட combination தான் இந்த buffer solution அப்படிங்கிறது. So weak acid and its own salt or weak base and its own salt. So first acidic buffer solution means weak acid. So now the weak acid is acetic acid and its own salt is sodium acetate. The sodium acetate is formed by reacting the acetic acid with the sodium hydroxide. A weak acid strong base கூட react பண்ணி produce பண்ணக்கூடிய salt. The combination of acetic acid and sodium acetate is an example for acidic buffer. The second one is basic buffer solution. So basic buffer na weak base and its own salt. That weak base reacts with a strong acid, it forms salt. Okay ba? So weak base reacts with a strong acid, it forms a salt is an example of basic buffer solution. So ammonium hydroxide, it is a weak base, it reacts with strong acid HCl, it forms a salt ammonium chloride. So weak base ammonium hydroxide and ammonium chloride, the mixture is known as basic buffer solution. So two types of buffer solution is very important one, acidic buffer solution, basic buffer solution. The buffer solution is only made by the weak acid or weak base. So the weak acid அது எதோட combined ஆயிருக்கும்? Its own salt. So salt எப்ப produce ஆகும்? Acid reacts with the base, there is a formation of salt. So இங்க weak acid அப்படிங்கறனால strong base கூட react பண்ணி salt produce பண்ணும். The second one basic buffer. So weak base and its own salt. That salt is formed by the base reacts with a strong acid. It gives a basic buffer solution. So next one is buffer action. The study of the buffer solution to resist the changes in their pH. So pH value எப்படி resist பண்ணுது அப்படினு ஸ்டடி பண்றது என்னதுப்பா buffer action. So அது ஒரு எக்ஸாம்பிள் வச்சு எக்ஸ்பிளைன் பண்றோம். So we have to take the acidic buffer. Acetic acid which is partially dissociated. Weak acid என்னது partially dissociated. So acetic acid is partially dissociated into acetate ion and H plus ion. Acetate ion ஆவும் H plus ion ஆவும் dissociate ஆகுது. The second one is sodium acetate. So salt, so it is completely dissociated. So partial ionization means we give the double headed arrow mark, equilibrium sign கொடுப்போம். அதை completely dissociated means only forward arrow mark, complete reaction is completed. So it will be dissociated to an acetate ion and Na plus ion. Acetate ion Na plus ion produce பண்ணுது. This is the mixture. This is the buffer mixture. To that buffer solution we are adding an acid. So mixture though both are present in the same compound. ஒரே ஒரு கண்டென்ட்லயே present ஆயிருக்கு. So இது கூட என்ன ஆட் பண்றோம் by adding an acid, small amount of acid. So acid means which gives an H plus ion. Arrhenius concept la பாத்திருக்கோம். So acid means which produces H plus ion. Base means which produces OH minus. So here by adding an acid, so acid means which produces the H plus ion. That added acid to that mixture. In the mixture la acid add பண்றோம். அப்ப H plus add பண்ணா acidic content increase ஆச்சுனா என்ன changes நடக்கணும்? What we expect? There is a decrease in the pH of the solution. But அதுக்கு பதிலா the added H plus ion immediately combined with the acetate ion and it will be formed the undissociated acetic acid. This equation is given here. So acetate ion reacts with the added H plus ion. It gives the unionized acetic acid. So added H plus ion enadha, it will be immediately neutralized. That means it's immediately combined by the acetate ion and forms a neutral acetic acid. நம்ம கொடுத்த H plus ion solutionல same formatல H plus ஆவே present ஆயிருந்ததுனா pH of the solution will be reduced. அப்படிதான் நடக்கும். But the added H plus ion, it is immediately combined with the acetate ion. It forms a neutral acetic acid molecule. So that the pH of the solution remains same. That means the pH will not be changed. pH change ஆகாது. So நம்ம expect பண்றது the pH of the solution is decreases, but the added H plus ion is combined with acetate, it forms neutral acetic acid. So the pH of the solution remains same. The next one is by adding base. So base means according to Arrhenius concept which produces the OH minus ion. The compound is a base. இப்போ base பதிலா நம்ம என்ன ஆட் பண்றோம்? We are adding OH minus. So when the OH minus ion is added to this buffer solution, the added hydroxyl ion combined with acetic acid, it forms a neutral water molecule. That means the OH minus ion is neutralized by the acetic acid. It forms a neutral water molecule. So if the added OH minus ion is present in that same solution, we expect there is increase in that pH. Base ஆ pH value என்ன increase ஆகும் greater than 7. So நம்ம என்ன expect பண்றோம்? Base add பண்ண உடனே pH value must be increases. But அதுக்கு பதிலா என்ன ஆகுது? The added OH minus ion base, it will be immediately neutralized by an acetic acid. It forms a neutral water molecule. So there is no more OH minus ions are present in that solution. So the pH of the solution remains same. That means it's not changed. pH of the solution என்ன ஆகாது? Change ஆகாது. That is the buffer solution. So what is meant by buffer solution? The solution which resists the changes in the pH of the solution by adding a small amount of acid or base, not a large quantity. கொஞ்சமா add பண்ணும்போது இது changes இல்லாம இருந்தா அது என்னன்னு சொல்லலாம்ப்பா? Buffer solution சொல்லலாம். So ஏன் change ஆகல? So why the changes is not occurred on here? That is explained by buffer action. So buffer action is explained by using the acidic buffer. So in the same way we also use it to explain the basic buffer. Basic buffer நம்ம explain பண்ணிக்கலாம். Right. So இன்னைக்கு கிளாஸ்ல நம்ம என்ன பார்க்கறோம்னா salt hydrolysis. So ionic equilibrium one of the topic salt hydrolysis. So salt hydrolysis பத்தி நம்ம பார்க்கிறதுக்கு முன்னாடி what is neutralization? இது last yearல 11th portionலயும் பார்த்திருக்கோம். even நீங்க 10th classலயும் படிச்சிருப்பீங்க. So neutralization அப்படிங்கிறது என்னது? When an acid reacts with the base, it forms a salt and neutral water molecule. This reaction is known as neutralization reaction. So ஒரு acid base கூட react பண்ணி it produces salt and neutral water molecule. This reaction is known as a neutralization reaction. So the newly formed salt during the neutralization reaction is completely dissociated into an constituent ions. So ஒரு salt form பண்ணுது, for example sodium hydroxide, a strong base, it reacts with the acid HCl, it forms sodium chloride salt. So the sodium chloride salt is completely dissociated into an ions in water. So the aqueous solution la constituent ions are produced பண்ணும். The ions are immediately hydrated by water. So it may be both the cation and anion are hydrated by water, or any one of the cation and anion is hydrated by water. So by using the hydrolysis of water, the aqueous solution of salt produces its constituent ions. The ions are immediately hydrolyzed by the water. That aqueous solution la the ions in hydration nadakkum. So and the part da enna solrom salt hydrolysis. So the salt hydrolysis is classified depending on the nature of the salt, nature of the acid and base. So strong acid or weak base. So the acid base oda nature depend panni the hydrolysis of salt is classified into 4 types. The first one is salt of strong acid and strong base. So strong acid and strong base react panni produce பண்ணக்கூடிய salt hydrolysis நடக்குமா நடக்காது. So first one enadra, so salt of strong acid means strong acid is nitric acid. So nitric acid is a strong acid, and strong base sodium hydroxide, it is a very strong base. So acid and base reacts, it forms a salt, sodium nitrate and water molecule. So initially பார்த்திருக்கோம். So acid என்ன form பண்ணும்? So salt means it is completely dissociated into an ions. Ions are completely dissociated ஆகும். So sodium nitrate is completely dissociated into Na plus and NO3 minus. So partial dissociation we give in the double gated air mark. So complete dissociation in the strong component irundhuna complete dissociation is occurs, only forward air mark is given. So in the first case sodium hydroxide and nitric acid both are strong, so single forward air mark only given. So here the salts are completely dissociated, salts ellame na completely dissociate agum. So sodium nitrate is completely dissociated to an Na plus and NO3 minus. So which one is hydrolyzed, which ion, that means it may be a cation or anion, which one is hydrated by the water. So edu water ala hydrolysis agum. So it is based on it is formed from where. So இது எதோட conjugate acid இருக்கு, conjugate base இருக்கு, depending on that it is hydrated. So for example conjugate acid and base of weak acid or weak base. நம்ம conjugate acid base pair எதுல ஸ்டடி பண்ணிருக்கோம்? The conjugate acid base pair is studied in Lowry-Bronsted concept. அதுல பார்த்திருந்தோம். So அங்க என்ன மட்டும் பார்த்திருந்தோம்? The species differed only by a proton is called conjugate acid base pair. So adala mattum nam paathirom. So inga enadra not only by H plus mattum illa some other topics use panni kudukurom. So enama, so the salt it is dissociated to Na plus and NO3 minus. The ions is formed from where, edhila irundhu produce agudungra base panni kudukurom. That Na plus ion is formed from sodium hydroxide. Na plus ion is formed from sodium hydroxide. So sodium ion, so sodium hydroxide is a strong base. A strong base form பண்ண Na plus ion என்னப்பா weak acid, அதுக்கு reversible தான இருக்கும். So weak acid. So Na plus is the conjugate acid of strong base. Conjugate acid of strong base. Then second anion NO3 minus. So the NO3 minus is formed from strong acid. This is a strong base. Nitric acid is a strong acid. So the strong acid, the nitrate ion is formed from strong acid, nitric acid la irundhu produce agudhu. So the nitrate ion is a conjugate base of strong acid, conjugate base of strong acid. So idukku munadi paathirukom conjugate acid and base of, so weak acid or weak base only reacts with water. So appo weak acid weak base la produce agakuriya conjugate acid base pair da enna it reacts with water, but here the formed conjugate acid and base both are produced from strong base and strong acid. Strong base strong acid la irundhu produce agudhu. So those two both are not having no tendency to react with water. So both are having, so both means Na plus ion and NO3 minus ion having no tendency to react with water. So hydrolysis is not possible. So if the salt is produced from the strong acid and strong base, it has no tendency to react with water. So salt hydrolysis is not possible for the compound is formed from strong acid and strong base. So the water is partially dissociated into H plus and OH minus, which have equal number of H plus and OH minus ion. So the pH is constant due to the no possibility for hydrolysis. So the solution is neutral. So hydrolysis of strong acid and strong base பார்த்தோம். Hydrolysis of salt of strong acid and strong base is not possible அப்படின்னு சொல்லி பார்த்தோம், because both the ions are from the salt is formed from strong acid and strong base. So hydrolysis is not possible. Second case is hydrolysis of salt of strong base and weak acid. So one of the component is weak acid. So hydrolysis is possible. So first one, the sodium hydroxide is a strong base, reacts with weak acid, acetic acid. Strong base reacts with weak acid, acetic acid. We get sodium acetate as a salt and water. Sodium acetate salt form ஆகுது. So sodium hydroxide reacts with acetic acid. It gives sodium acetate and water. So the reaction occurs in between the strong base and weak acid. We get the salt. So generally acid base கூட react பண்ணாவே salt form பண்ணும். Depending on the nature of the acid and base, that means whether it is a strong or weak, there is a formation of salt and it is further hydrolyzed or not. அதுதான் பார்க்கிறோம். Right. So here the sodium acetate is formed as a salt. So sodium acetate is a salt, so it is completely dissociated into an ion. So salt எல்லாமே என்னாகும், in its aqueous solution it is completely dissociated. So sodium acetate is dissociated to form acetate ion and Na plus ion. So acetate ion and Na plus ion form பண்ணும். The acetate ion is a conjugate base of weak acid. Acetate ion is formed from weak acid, acetic acid. So இது weak acid இது கண்டிப்பா ஸ்ட்ராங்கா தான் பிரசன்ட் ஆயிருக்கும். So acidல இருந்து ஃபார்ம் ஆறனால base. So acetate ion is a conjugate base of weak acid. So weak acid ல இருந்து ஃபார்ம் ஆச்சுனா it must be hydrolyzed. That means it has a tendency to react with H plus ion from water. Tendency to react with the water. So the acetate ion anionic form இருக்கிறனால it must react with the positive ion in water, that is H plus from water, to form unionized acid. Acetate ion H plus கூட react பண்ணும்போது எதை form பண்ணும், it forms unionized acid molecule form பண்ணும், acetic acid form பண்ணும். Then the second ion formed in this reaction is Na plus ion. That Na plus ion is formed from strong base. So இது ஸ்ட்ராங்கா இருந்துச்சுன்னா கண்டிப்பா இது என்னவா இருக்கும், வீக்கா தான் பிரசன்ட் ஆயிருக்கும். At the same time, so it is a base, it forms an acid molecule. So Na plus is the conjugate acid of strong base. If it is formed from the strong electrolytes, it's not hydrolyzed. So it's not reacts with water. So conjugate, so Na plus is the conjugate acid of strong base. So it has no tendency to react with water molecule. So water molecule present ஆயிருக்க OH minus கூட என்ன ஆகாது, react பண்ணாது, because it's formed from strong base. So one is must, that is the if the ions formed from salt, it does not react with the water depending on whether it is formed, where it is formed, எதுல இருந்து form ஆகுது, from strong acid or weak acid, or strong base or weak base. So the ions from the salt is formed from, the ions are formed from weak acid or weak base, it must react with the water. So weak acid weak base ல இருந்து form ஆன ions ஆ இருந்ததுன்னா கண்டிப்பா water molecule கூட react பண்ணும். Or if it formed from the strong acid or strong base, it does not react with water. So Na plus is formed from the strong base, so it has no tendency to react with OH minus ion from water. Water molecule இருக்க OH minus கூட react பண்ணாது. Then acetate ion, so it is a conjugate base of weak acid, so it reacts with the water, it forms unionized acetic acid and OH minus. That means the solution contains excess of OH minus. So கொஞ்சம் முன்னாடி பார்த்தோம் salt of strong acid and strong base, there is no formation of OH minus and H plus. Equal number of H plus and OH minus ions are present from water. So water ல இருந்து H plus and OH minus equal number ல present ஆயிருந்து, so it is a neutral, no hydrolysis னு சொல்லியாச்சு. But here the acetate ion reacts with the water, it forms unionized acetic acid, in addition to that it forms OH minus. A compound which produces, or the solution which contains a H plus ion, it is acidic, or it's the solution which contains OH minus, it is a basic compound. So the solution which having OH minus, so the solution is basic. So அதனால the solution என்னவா இருக்கு, basic ஆ இருக்கு. If the solution is basic means the pH value is greater than 7. So here the concentration of OH minus is greater than the concentration of H plus ion. So the solution is basic and the pH value is greater than 7. So next we derive the hydrolysis constant. Hydrolysis constant and pH for this hydrolysis of salt of strong base and weak acid. So next is the hydrolysis constant KH. Number dissociation constant for an acid, dissociation constant for base papilla. So in the same way, the hydrolysis process nadakudhu. So if we attain the equilibrium condition, any reaction, so dissociation constant for acid or dissociation constant for base or hydrolysis constant KH. So KH is known as a hydrolysis constant. So எதுவா இருந்தாலும் சரி, if it attain the equilibrium condition, we applying the law of mass action. So hydrolysis constant KH is equal to as usual concentration of the product by concentration of the reactant. இப்போ hydrolysis of acetate ion பார்த்திருந்தோம் இல்லையா? So அதில் product side என்ன present ஆயிருக்கு? Acetic acid and OH minus ion by in the reactant side acetate ion and water. But water is used as a solvent. So it is used only in a negligible quantity. So the water is a minimum quantity of water is only used for the hydrolysis of acetate ion. So in the acetate ion hydrolysis பண்றதுக்கு நம்ம என்ன எவ்வளவு quantity எடுத்துக்கோம்? Just little quantity. But it is a solvent. We have to take large excess. எடுத்துக்கிறது large இருந்தாலும் அதில் யூஸ் பண்ணது utilize பண்ணது எவ்வளவு? Just a minimum quantity. So the changes in concentration of water is considered to be a constant. So the hydrolysis constant KH is written as concentration of acetic acid and concentration of OH minus by concentration of acetate ion. Then so the acid is formed from the conjugate base is formed from the weak acid acetic acid. So weak acid means partially ionized. So on the conjugate base which one is hydrolyzed? So the hydrolyzed ஆனது எந்த ஆசிட்ல இருந்து ஃபார்ம் ஆகுது or எந்த பேஸ்ல இருந்து ஃபார்ம் ஆகுதுங்கறத டிபெண்ட் பண்ணி acetic acid. So the acetic acid is a weak acid. So it is partially dissociated as an acetate ion and H plus ion. Then they applying the law of mass action, that is dissociation constant for weak acid. இதெல்லாம் முன்னாடி பார்த்திருக்கோம் strength of acid and basesல. So dissociation constant for acid Ka is equal to as usual the concentration of the products by concentration of the reactants. This equation is considered to be 2. So by multiplying the equation 1 and 2, that means the dissociation constant and hydrolysis constant KH into Ka இந்த ரெண்டையும் multiply பண்றோம். So finally we get acetic acid cancel ஆயிரும், acetate ion should be cancelled. So finally we have the concentration of OH minus and concentration of H plus ion. So already we know that the product of the hydronium ion and hydroxyl ion is equal to ionic product of water Kw. Ionic product க்கு equal present ஆயிருக்கும். So KH into Ka is equal to Kw. The product of hydrolysis constant and dissociation constant is equal to ionic product of water Kw. So KH is known as a hydrolysis constant. KH is known as a hydrolysis constant. So already we seen that from Oswald dilution law, Ka is a dissociation constant for an acid. So for Ka is equal to alpha square C. Similarly, but dissociation constant க்கு alpha degree of dissociation apply பண்றோம். For hydrolysis constant KH, we applying the H square hydrolysis constant. Then for basic solution, the concentration of OH minus is equal to root of Kb into C. For this solution, the salt solution, the concentration of OH minus is equal to root of KH into C. By using the values, we derive the pH of this salt solution. So pH of the salt solution, so salt solution of strong base and weak acid. இப்போ hydrolysis of salt solution of strong base and weak acid பார்த்தோம். So இப்போ அந்த சொல்யூஷனோட pH எப்படி calculate பண்ணலாம்? So இப்போ acidic solution இருந்தால் directly the pH is calculated from the formula of minus log of concentration of H plus ion. If it is an acidic solution, the pH of the solution is calculated by minus log of concentration of H plus ion. But it is a basic solution. The concentration of OH minus is greater than the concentration of H plus ion. But basic solution க்கு pH value எப்படி calculate பண்ணலாம்? First of all we calculate the pOH for the basic solution. pOH கண்டுபிடிச்சு then we calculate the pH value. So for those solution we calculate the pH by using the relation between pH and pOH. So pH plus pOH is equal to 14. Then pH is equal to 14 minus pOH. So pOH oda formula நமக்கு already தெரியும். pOH is equal to minus log of concentration of OH minus ion. So minus into minus plus. So 14 plus log of concentration of OH minus. So by using Oswald dilution law, so இதுக்கு முன்னாடி இந்த இதுல பார்த்திருந்தோம், concentration of OH minus is equal to root of KH, hydrolysis constant into C. So for the concentration of OH minus, we substitute those values KH into C. So root cancel பண்ண power 1 by 2. So KH into C power 1 by 2. Then 14 plus log KH oda formula நம்ம பார்த்திருக்கோம், KW by Ka into C power 1 by 2. So when we have to take a logarithm, the 1 by 2 powers come before. So 14 plus 1 by 2 log KW. Multiplication la irukradhu ellame positive sign. When you have to take a log, the multiplications are in positive sign, the division is in the negative sign. But plus 1 by 2 log KW. So multiplication la irukku, numerator la present aayirukku, plus 1 by 2 log C. Ka, dissociation constant for an acid, is in the denominator. So minus 1 by 2 log Ka. So plus 1 by 2 log Kw. So Kw is ionic product of water. So ionic product of water is 10 power minus 14. So 1 by 2 log Kw value என்ன find out பண்ண போறோம். So 1 by 2 log Kw is equal to 1 by 2 log Kw value என்னப்பா 10 power minus 14. So powers இருக்குது என்ன log எடுக்கும்போது முன்னாடி வந்துரும். So minus 14 powerல minus 14 present ஆயிருக்கு. So minus 14 by 2 log 10. Log 10 ஓட value என்ன 1. So minus 14 by 2 is equal to minus 7. So the value of 1 by 2 log Kw is minus 7. இப்போ 1 by 2 log Kw க்கு பதிலா value substitute பண்றோம். So 14 minus 7 plus 1 by 2 log C plus minus half log Ka க்கு பதிலா plus 1 by 2 pKa. We know that minus log Ka is equal to pKa. இல்லையா? அப்போ minus log Ka க்கு பதிலா we substitute the pKa value. So plus 1 by 2 pKa. Then pH is equal to 14 minus 7, 7 plus half log Kc plus log C plus half pKa. This is the pH of the solution for the salt is formed from the strong base and weak acid. So hydrolysis of salt of strong acid and weak base. So கொஞ்சம் முன்னாடி வரைக்கும் நம்ம என்ன பார்த்திருந்தோம், salt of strong acid and strong base பார்த்திருந்தோம். Next one is hydrolysis of salt of strong base and weak acid பார்த்திருந்தோம். So இப்போ third one, hydrolysis of salt of strong acid and weak base. So a salt is formed by the reaction between an acid and base. So due to the neutralization reaction, there is a formation of salt. So neutralization reaction நடக்கும்போது தான் salt produce ஆகுது. So இங்க என்ன type of acid base எடுத்துக்கிறோம், strong acid. The reaction occurs in between the strong acid and weak base. So here the strong acid is HCl, hydrochloric acid, reacts with the ammonium hydroxide. It gives ammonium chloride and water. So ammonium chloride salt is formed by the reaction between HCl and ammonium hydroxide. So ammonium chloride is a salt. So salt means it is completely dissociated into an ions in aqueous solution. So aqueous solution la complete ions are dissociate agum. So the ammonium ion and chloride ion is formed during the hydrolysis of ammonium chloride. The ammonium ion is a conjugate acid of weak base. Conjugate acid of weak base. So weak base ammonium hydroxide produces the ammonium ion. So weak base அப்படிங்கறனால கண்டிப்பா என்ன இருக்கும், conjugate acid. So conjugate acid of weak base. So if it is formed, the ion is formed from a weak acid or weak base, it can able to react with the water. Water கூட react பண்ணக்கூடிய capacity இருக்கும். So NH4 plus is the conjugate acid of weak base. So it has a tendency to react with OH minus from water molecule. So water கூட react பண்ணும். It specifically waterல present ஆயிருக்க OH minus கூட react பண்ணும். It forms unionized ammonium hydroxide molecule. When ammonium ion reacts with water, it forms unionized ammonium hydroxide molecule. The next one is Cl minus. So second ion formed in this reaction is Cl minus. The Cl minus is a conjugate base of strong acid from hydrochloric acid. So the ion is formed from the strong acid or strong base. It has no tendency to react with water. So it is formed from strong acid, has no tendency to react with the water molecule. Water molecule kuda react pannadu. So the ammonium ion has only ion to react with the water from ammonium chloride. So ammonium ion is hydrolyzed by water. It forms unionized ammonium hydroxide and H plus ion. So in the solution, the concentration of H plus ion is greater than the concentration of OH minus ion. So the solution is acidic. So a compound which having more number of H plus ion than OH minus, the solution is acidic. So pH value is less than 7. So acidic solution pH value less than 7. If it is a basic solution, the pH value is greater than 7. So it is acidic solution. The pH values must be less than 7. Kandipa 7 ku keela irukanum. So it is a hydrolysis process. So we are applying the hydrolysis constant KH is equal to concentration of the product by concentration of the reactant. So here the products are ammonium hydroxide and hydrogen ion by concentration of ammonium ion. But the concentration of water is negligible because it is a constant value. So a small quantity of water only used for the hydrolysis. So it is negligible. This is a hydrolysis constant KH. So the next one is, so the ammonium hydroxide formed as a weak base. So ammonium hydroxide weak base which is partially dissociated. So partially dissociated, we attain the equilibrium condition. So it dissociated to form ammonium ion and hydroxyl ion. Ammonium ion hydroxyl ion produce pannum. Then Kb weak base அப்படிங்கறனால நம்ம என்ன யூஸ் பண்றோம்? Kb dissociation constant for base. But Kb is equal to, as usual, the concentration of the products by concentration of the reactants. So we are applying the dissociation constant and hydrolysis constants are multiplied. But Kh into Kb is equal to, so the multiply பண்ணும்போது என்ன ஆகும்டா? So the concentration of ammonium hydroxide cancel ஆகும். Concentration of ammonium ion cancel ஆகும். So finally Kh into Kb is equal to Kw. What we get here? Concentration of H plus ion into concentration of OH minus ion. So the product of concentration of H plus and OH minus is equal to ionic product of water such as Kw. Kw ki equal present ஆயிருக்கும். So already we know that KH, the hydrolysis constant, is equal to H squared into C. So நம்ம முன்னாடி எந்ததுல பார்த்திருந்தோம்? Hydrolysis of salt of strong base and weak acid. So adula paathirundom KH value. So the KH value is obtained from the Oswald dilution law. Oswald dilution law la irundhu obtain pannittom. So KH is equal to H squared C, and then the concentration of H plus is equal to root of KH into C. It is also obtained from the Oswald dilution law. So pH of the salt solution. அப்ப hydrolysis of salt solution பண்றோம். Then we calculate the pH of the solution. And the salt solution ஓட pH value எப்படி இருக்கு? Because salt is neutral. But during hydrolysis it may be an acidic or basic. ரெண்டுல ஏதோ ஒரு formatல present ஆயிருக்கும். So இதுல நம்ம என்னன்னு பார்த்திருக்கோம்? The solution is acidic. So acidic னு பார்த்தாச்சு due to the more number of H plus ion. So இப்போ இந்த pH value எப்படி calculate பண்ணலாம்? So pH is equal to, already we know the formula, minus log of concentration of H plus ion. So H plus ion oda concentration oda value already we know that. So root of KH into C. So minus log of KH into C. So square root cancel பண்ணி என்ன கொடுத்திருக்கோம் பவர்ல 1/2 னு கொடுத்திருக்கோம். Okay? Then pH is equal to minus log of KH value எதுக்கு equal பா? KH is equal to KW by KB. So இங்க பார்த்திருக்கோம். KH into KB is equal to KW. அப்ப KH is equal to KW by KB. So in the value தான் நம்ம அங்க substitute பண்ண போறோம். So pH is equal to minus log of KW by KB into C power 1/2. So when we take logarithm, the power ல இருக்குறதுல என்ன ஆயிரும்டா? It comes forward, முன்னாடி வந்துரும். அப்ப என்ன ஆகும்? minus 1/2 log KW. So numerator ல இருக்க ஃபார்ம் எல்லாமே பிளஸ் ஆ இருக்கும். log எடுக்கும்போது denominator ல இருக்குறதெல்லாம் என்ன ஆயிடும்? மைனஸ் ஆயிடும். அப்ப minus half log KW minus half log C. So denominator ல இருக்குறது denominator வரும்போது என்ன ஆயிரும்ப்பா? மைனஸ் ஆகும். ஆல்ரெடி ஒரு மைனஸ் இருக்கு. So minus into minus plus 1/2 log KB. So 1/2 log KW ஓட value minus 7. So salt hydrolysis of salt of strong base and weak acid நம்ம derive பண்ணி பார்த்திருக்கோம். So நம்ம இந்த value மட்டும் எடுத்துக்கிறோம் இந்த இடத்துல. So 1/2 log KW is equal to minus 7. So இது எப்படி நம்ம prepare பண்ணோம்? So KW ஓட value 10 power minus 14. அப்ப log KW 1/2 log 10 power minus 14 value simplify பண்ணும்போது we get as minus 7. And then negative logarithm of KB is equal to PKB. Those two values are substituted in this equation. So pH is equal to 1/2 log KW ஓட value minus 7. Already ஒரு minus இருக்கு. So minus into minus plus. So plus 7 minus 1/2 log C. ஸோ இங்கே மைனஸ் log kbங்கிறது pkbக்கு ஈக்குவல் அப்போ ப்ளஸ் இங்கே 1/2 இருக்கு அப்போ minus 1/2 pkb. So by using this equation we calculate the pH of the solution, salt solution, which is formed by the strong acid and weak base.